Okay, so here's our problem. We're figuring out if we did an experiment where we put room temperature water in a vacuum and reduced the pressure until it boiled, what was the pressure when it boiled? And to do this we have to use the Clausius Clapeyron equation again. And there it is, at least the form that we're going to use. So for when we use it, the gas constant R is going to be 8.31. And the units of that are joules over Kelvin times mole. So all the other numbers in here have to be in terms of joules, Kelvin, and mole. So we absolutely have to use absolute temperature. So we need to report T2 and T1 in Kelvin. First, let's think about P1 and T1. This is kind of like the reference temperature and pressure. So the P1 can be normal atmospheric pressure, and the T1 is the temperature at which something boils under normal atmospheric pressure. Here we're talking about water, so T1 is 100 C, but we need to turn that into Kelvin, so we add 273. And the pressure is, that P1, the pressure at which the water boils at 373 is just 1 atmosphere. And to keep things simple, let's just keep that in the units of ATM. Alright, then we can look up or Google the enthalpy of vaporization of water, and we have to report it in units involving joules and moles, so that's going to be in joules per mole. So we got that. Okay, so let's step back and think about what we're doing with this equation. We want to find the pressure at which something boiled, at which the water boiled at 23 degrees Celsius. So what we're really trying to find is P2 here, that's our unknown. And we know T2, which is 23 degrees Celsius, but again we need that to be in terms of absolute temperature in Kelvin. So to convert that, we add 273 and get 296. Alright, so now we're actually ready to do some math. Let's solve this equation for P2. Here's a little trick. ln P2 over P1 is the same thing as ln P2 minus ln P1. So we can kind of separate the P2 and P1 there. And I went ahead and put in 1 ATM for P1. And I'm going to go ahead and put in our delta H vap and our R. And I put in our T2 and T1. Hey, pretty convenient that ln of 1 is 0. And I'm plugged in a calculator and got this. And also I just forgot we should put in our negative sign there. So this is negative on the right side. I just did a little multiplication. And now a little bit of a tricky part. ln is natural log, which means log base e. So this statement here means that if we take e to the negative 3.415 power, that'll give us P2. That's better. This isn't too hard to do. E is just a stand-in for a very specific number, so your calculator knows what that number is. So if you just put in e to the power of negative 3.415, you should get 0.033, and that is in ATM, because that's the unit of pressure we decided to use. And if we're curious, we can convert that to torr. There's 760 torr in 1 ATM, so that's our conversion factor, and we get 25 torr as our answer.